Hey guys, so this is the unit trigonometry, so we've been working on. Our objective today is to evaluate trig functions on the coordinate axis. I know the axes, we know that we've already been going over this. I'm going to review just to make sure we're clear on some things, and then we're going to move on to two more subjects. So, whenever you're drawing your angles, you always start with the initial side, which is the positive x-axis. So this is always where your theta will begin. Your terminal side is where it ends. And so if we draw this as theta, this is the red line is the terminal side and the green line is the initial side. The initial side is always the same. The terminal side is the thing that changes, okay? Positive angles are always measured counterclockwise. Counterclockwise is in this direction, okay? I know here you might call it anti-clockwise. I call it counterclockwise, so I need you to know that I'll be using that terminology, okay? Some main points on the x and y coordinates when you're talking about degrees. At the beginning, you're starting with 0 degrees. And then when you get up to the positive y-axis, you're talking about 90 degrees. And then when you get to the negative x-axis, it's 180. And then when you come down to the negative y-axis, that's 270. And then when you make the full circle, that's 360. Okay, I know that you guys helped me out with that the last time, like you knew where all of your stuff was. Just want to make sure that we're clear. So if we said 30 degrees, that would be in the first quadrant, which is right here. And note that these are not drawn to scale. I'm not a good drawer. So this is theta 1. And then theta 2, which is 195. That would be past the negative x-axis and into the third quadrant. So about right here. That's going to be our Q2. And then our Q3, which is 290, is going to be past the negative x-axis. And so that's right here, Q3. Okay? Note that Q1 starts at the positive x-axis. Note that Q2 also starts at the positive x-axis, and so does Q3. They all start at the positive x-axis. Okay? Moving on. When you're talking about the unit circle, it's called a unit circle because the radius is 1. The center is always at 0, 0. Okay, we're going to zoom in on the first quadrant of it. And I wanted to go back over why the point was cosine of theta and sine of theta. Okay, so if I made this into a triangle, into a right triangle, okay, this distance would be x. So down here, this would be some x distance, right? Over here, this would be some y distance, okay? So I know that the radius is 1, and typically this point would be the x value and the y value, right? But if I wanted it in terms of cosine and sine, this is why that point exists as cosine theta, sine of theta. Because when I'm looking at theta, the cosine of theta is the x over the hypotenuse, so the adjacent, which is x, and the hypotenuse, which is 1. Well, these are the same things, right? X divided by 1 is just x. So you have cosine of theta equals x. So I can substitute cosine into here. And the same thing with y. If I wanted to put y in terms of a trig function, it would be sine of theta equals y over 1, the opposite over the hypotenuse. And that's the same thing as sine of theta equals y, because y divided by 1 is just y. So that's why we can label these points as cosine theta, sine theta, okay? I just wanted to make sure that we were clear on why you can do that. Now, for example, if we wanted to find the terminal point, okay, for theta 59 degrees, theta equals 59 degrees, all we'd have to do is put in 59 into the cosine and into sine. And then you get the point, the terminal point. So cosine of theta equals 0.515. And the sine of theta, or sine of 59 is 0.857. Okay, and so that would mean, like, if it asked for the exact one and you can't find it because it's not a special triangle, then you could just say, if it's asking for exact, you would say cosine of 59, sine of 59. If it says round to the significant figures, then you would say 0.515, comma, 0.857. Okay, so this is for exact, and this is for 3 significant figures. Okay, again, this, when we say exact, it's only because it's not a special right triangle. So the 30, 60, 90 degree triangle, you can give an exact number, not just a function. The 45, 45, 90 degree triangle, you can also give a exact number, not just a function. Okay, so for example, the exact coordinates of the terminal point when it equals 60, we go ahead and I like to draw it just so that way I know what it looks like. And it's just a rough sketch, but this is 60. I know that this is going to be 1, and I just draw my triangle. So I know that across from the 60, I always have the square root of 3, but I have to divide it by 2, right? So across from the 90 degree angle, you should have 2, but we have a 1, so that means you have to divide it by 2. So that means all the sides should be divided by 2. So the y is going to be square root of 3 divided by 2. The x is going to be 1 divided by 2. Because across from the 30 degree angle, you should always have a ratio of 1. So that means that the exact coordinate for the terminal point right here is going to be 1/2 square root of 3 over 2. Okay, that is the answer. So find the value to 3 significant figures of the terminal point when beta equals 43 degrees. Same thing, make a rough sketch just so that way you can draw it. 43 degrees, this is 1. You want to find this point. I know that this is going to be cosine of 43, and this is going to be sine of 43. It wants it to 3 significant figures, so when I put that in a calculator, I get 0.731, comma 0.682. Okay, last one, find the exact value of the terminal when it's equal to 30 degrees. And again, make a rough sketch and plot the theta 30 degrees. I know that this should be a 2, the hypotenuse, but it's a 1, so remember that we're dividing by 2. Across from the 30 degrees, you should have 1, but we're dividing it by 2. Across from the 60, you should have square root of 3, but we're dividing it by 2. So the point is going to be the x value, which is square root of 3 divided by 2, and the y value, which is 1/2. If the terminal point for theta is 0.408 and 913, or 0.913, what is theta? So this is really simple. All you have to do is take the arc cosine or the arc sine of your x, y value respectively. So I could either do, when I say arc sine, I mean the inverse of cosine, or when I say arc sine, I mean the inverse of sine. So inverse of cosine or arc cosine of 0.408, or you could do sine -1, or the inverse of 0.913, right? Either one of those will get you the same answer, and you just round to the nearest degree, so 66 degrees. Okay, now moving on to obtuse angles. Okay, obtuse angle is anything greater than 90 or 90 or greater. So greater than 90. So if I say that this right here is theta and this is theta, that means that they make the same triangle. Okay, they make congruent triangles. So that means that whatever this is should be cosine of theta sine theta. Sine theta. And over at A, you should have the same thing, right? Because they're congruent triangles. But looking at it from the Cartesian coordinates, we know that the x value over here should be negative, right? So instead of positive cosine theta, you're just going to have negative cosine theta. But the sine of theta, the y value, is the same, right? Because it's right here. But the cosine of theta is positive over here and negative over here, because that's this distance right here. Okay, so when you have theta, but it's on the other, it's in quadrant 2, you just take the negative cosine of it. Okay, but what is that degree, right? So we're saying that if theta's over here, that's fine. Like, you still get the same point, except that the x value is negative. But what is that angle? So it's not theta, right? Because our angle has to start from the positive x-axis and move to the terminal side, right? So the initial is always at the positive x-axis, and then it goes to the terminal side here. Okay, so how do I find that angle? Well, it equals 180 degrees minus theta, right? Because if I go all the way, this is 180 degrees. So if I take away this theta, then I get what's left over. So the reason why we say this is, or the whole reason for going over this is because it helps with the identities that we're going to use later. And the identity is cosine of theta equals negative cosine of 180 minus theta. And sine of theta is just going to be the same no matter what, but it's sine of theta minus, or sine of 180 minus theta. Okay, so these are some trig identities that we're going to use later on in the unit. But you need to know why they exist, and that's because of this diagram right here. Because they are the same triangles, it's just in a different quadrant. Okay, so if we wanted to find the terminal point for theta equals 30 degrees and its obtuse angle, right? So we want to find the theta, this one right here, and we want to find this b right here. Okay, so the terminal point for 30 degrees, we already found it, and it was, in an earlier slide, we found it as square root of 3 over 2 and 1 over 2, right? So if I wanted to look at the obtuse angle, it would just take this x value and turn it into a negative. So we found the terminal point for theta equals 30 degrees. We want to find the terminal point for its obtuse angle. which would be negative square root of 3 over 2, 1 over 2. Okay, so this is for theta equals 30, and then the obtuse angle would be 180 minus 30, which equals 150. Here, we want to find the terminal point, or the terminal point is for theta is 0.515 and 0.857, and we want to find its obtuse angle. So first we're going to find theta, and then we're going to find the obtuse angle by subtracting theta from 180 degrees. Okay, so we could do cosine, or arc cosine of 0.515. This gives us 57 degrees. And if we wanted to find the obtuse angle, it would be 180 minus 57, which is 123. And that's the obtuse angle. The obtuse angle's terminal point would be the same as theta's, except that the x would be a negative. So it would be negative 0.515, comma, 0.857. I think I wrote that down right. Yeah. Okay. So it's just a matter of knowing which one you're talking about, the obtuse or the acute angle. And finding it is pretty easy. Gradient. Gradient, you'll hear me refer to as slope, just because I'm from the States and that's what we call it. But the gradient is just the change in y over the change in x. So here, it goes through the center, the origin. So xy would just be the change in x, which would be x minus 0, the change in y would be y minus 0 over x minus 0, which is just y over x. And because we've been putting these in trig functions, it would just be sine of theta over cosine of theta, which we know to be tangent of theta. So if I wanted to find the tangent of the gradient, I would just do tangent of theta, which is tangent of 130 degrees, which gives us negative, let me move this over. That gives us negative 1.191. So again, the gradient is just the change in y over the change in x. Because this point, this line goes through 0, 0, then the change is just y minus 0, x minus 0. And we can also write that as sine of theta over cosine of theta. And that is just tangent of theta. Okay, so if you're looking for the gradient of any degree, you just put in the theta that always starts at the positive x-axis and then goes to the terminal side. You put that into tangent of theta and it'll give you the gradient. So this this line's equation would be y equals negative 1.91 x. That would be the equation of that line. Okay, so that's all, I do believe. Yep. Okay, so if you have any questions, write them down. You're going to be asking them when we meet again on, I think it's Thursday. But, and if you have any feedback, write that down so that way I can make these videos better if we continue with them. Okay? Have a nice night.